Hi and welcome to MacSteve Tutorials. In this lesson, you are going to learn about factorization and prime factorization. These topics will become very useful when you start to learn about fractions and algebraic expressions, so it's essential to understand them. So, what do factors and factorization represent? Well, factors are numbers which you multiply together to get another number. For example, 5 times 2 is 10. Here, 2 and 5 are factors of 10. So when you want to factorize some number, basically you're looking for all numbers that can divide that number. For example, let's factorize number 14. The factors of 14 are 1, 2, 7 and 14, because all these numbers evenly divide 14. 14 divided by 1 is 14, or divided by 2 is 7. Now let's talk about prime factorization and prime numbers. Prime number is a number which can be divided only by itself and by 1. Some examples are 2, 3, 5, 7, 11, and so on. As you can see, all these numbers are divisible only by itself and by 1. For example, 3 can only be divided by 3 and by 1. If you try to divide 3 by any other number, you will get decimal number. Opposite of prime numbers are composite numbers. Numbers such as 4, 6, 9, 20, basically all other numbers. Now, why did I mention them? Well, because all composite numbers can be decomposed into the set of prime numbers. So when we talk about prime factorization of some number, we are talking about listing of all prime numbers which when multiplied together give that number. The best way to understand the concept of prime factorization is to solve some problems. So in first example we will find prime factors of number 12. To do that, we are going to construct factor tree. The branches of this tree consist of any two numbers you can multiply together and get 12. So, first two branches are 2 and 6. Since 2 is prime number, we end the left branch. Next, 6 can be written as 2 times 3. Now 2 and 3 are prime numbers, so we end the right branch. All these numbers at the bottom of the tree are prime numbers, so we can say that 2 and 3 are prime factors of 12, and the 12 can be written as 2 times 2 times 3, or 2 squared times 3. So please remember, when you do prime factorization, you're looking for the numbers at the bottom of the branch. Now let me show you one more thing. 12 can also be written as 3 times 4. Here, 3 is prime number, so there is no need to go any further. 4 can be written as 2 times 2, and again, prime factors are 2 and 3. Here I wanted to show you that there are many ways to get to the bottom of the branch, but you will always get the same prime numbers if you do it correctly, of course. In first example, we are going to find prime factors of 18. 18 can be written as 2 times 9. Since 2 is prime number, we end the left branch. Now 9 can be written as 3 times 3. Hence prime factors are 2 and 3, while 18 can be written as 2 times 3 squared. In this example, we are going to find prime factors of 30. We can write 30 as 5 times 6. 5 is a prime number, so we end the left branch. Next, we can write 6 as 2 times 3. So prime factors are 2, 3 and 5, while 30 can be written as 2 times 3 times 5. Now let's find the prime factors of 51. We can write 51 as 3 times 17. Here prime factors are 3 and 17, and 51 we can write as 3 times 17. In this example we are going to find prime factors of 80. 80 equals to 8 times 10. Now 8 can be written as 2 times 4. 2 is prime number, so we stop here. Next 4 can be written as 2 times 2, and we end here also. Now 10 equals to 2 times 5, so prime factors of 80 are 2 and 5, while 80 equals to 2 to 4th times 5. Now let's find prime factors of 48. 48 can be written as 3 times 16. 3 is prime number, so we end the left branch. 16 can be written as 4 times 4. Now 4 we can write as 2 times 2, and here the same. So prime factors are 2 and 3, while 48 equals to 2 to 4th times 3. Thank you for watching this video. If you want to be notified about new videos, please subscribe to my channel. In case you want some specific subject to be explained, leave your comments and share this video.